Unit 4, Lesson 3. So now we're doing solving linear inequalities with two variables without technology. So by two variables, now you're going to have a linear relationship. Okay, and we're going to be doing greater than or less than of linear functions. And you'll kind of see it's not as hard as it sounds. Okay, but let's do a quick review real quick, just making sure you understand your inequality signs. So these are less than, equal to. Okay, so remember, always read left to right. So these are your less thans. These are your graders. And this is not equal. Okay, and then these are an example of just having a single variable. Okay, when you have single variables, they're a little bit easier. You just solve for x. So this would be 4x minus 1 is greater than 7. 1 minus 2a is less than or equal to 5. And we would just solve. With the main rule being divide or multiply by a negative, you have to flip the inequality. Okay, and then we'll talk about, just go to the next example here real quick. Whoops. All right. So here is, I'm going to turn that down a little bit. So here's our first single variable example. All right, so all we're going to do on this one is we're just going to solve for x. So I'm going to distribute the negative 2. So that's going to give me 4, negative 6, negative 2x greater than 12. 4 minus 6 is a negative 2. Negative 2x greater than 12. Add 2. Negative 2x greater than 14. And then again, this is the main step here for inequalities, dividing by a negative. We've got to flip that. So that gives me x less than negative 7. That would be our answer there. When it says a test case in your book, your questions and your homework is going to ask for a test case. All it wants you to do is find or try an answer within your restrictions. So you're saying everything less than negative 7. So Josh, what's something less than negative 7? Negative 8. So I'm going to try negative 8. So I'm going to put negative 8 in the beginning, and it should be a true statement. So minus 2, 3 plus a negative 8 greater than 12. So we're trying 8. Negative 8, sorry. Okay, so let's go ahead. 3 plus a negative 8 is negative 5. So I have 4. 4 negative 2 times negative 5 greater than 12. A negative times a negative is a positive, so I get 4 plus 10, which is 14. Is 14 greater than 12? It is. So we just tested it. We're good to go. Okay, and then on part C, I'm going to do it up at the top here so I have more room. It says graph on a number line. When you have a single variable, you're going to graph it just on a simple number line. You're just going to go, okay, here's negative 2, negative 4, we'll put negative 8, so here's 7. It's open dot, and it's less than, so we're going to the left. You just draw an arrow to the left of negative 7. Okay, and that's the single variable inequality. We've kind of already done a little bit of that, so it shouldn't be super new, but okay. Yeah. Any questions or yet? Okay, so now for the kind of the a little bit more fun. Okay, so linear equalities in two variables. Okay, so now we're talking about the relationship of x and y. So a couple things we got to make sure that we are on board with is understanding which inequality it is. Understanding when we get these, we want to solve for y, because we want to think of everything in terms of, just kind of think of everybody, remember, we want to stay in this type of form, okay, slope form, right, because we want to do graphing of lines. So this one right here, I want to solve for y. Okay, this is P and Q. You just got to know they're going to go in alphabetical order. So think of that as your X, that's your Y. No big deal. Okay, but what we want to talk about is they're going to create a boundary line. So if I solve this, let's just do this one really quickly here. So I'm going to go 2x minus 3y greater than or equal to 6. I'm going to minus the 2x. I'm going to divide the negative 3. So it's going to give me y, got to flip the inequality, 2/3 x minus 2. We can graph this. Okay, it's going to give me a line that looks something like this. Down 2, up 2 over 3. It's going to give me a line like this. Okay, now see how it says less than or equal to? With the same concept as our open dot, closed dot, a solid line is equal to. A dotted line is not equal to. So if that was just a less than, I'd have to have this be a dotted line. Okay, we're going to get that's what they're talking about right here. Okay, so see, equal to's, solid, not equal to, just greater than, less than, dotted line. Okay, so let me just ask you just in general, now we're shading, this is what's different. Okay, it says less than or equal to. I'm going to call this section 1 up here, call this section 2 down here. Which section would you think you would shade if you were doing less than? 1 or 2? 2. 2, think below, right? Less than, below. Another thing you can use to help yourself is that you can think, here's your y-intercept. You want to shade the region below that. So down here, so I want all this down here. That would be your answer. Now what this means, or what this does for us, if I take any point, like way over here, let's say, what is that? Let's try 5, negative 10. 5, negative 10, is that in my solution set? Yes, so it should work. So watch. I'm getting kind of off track here, but I'm trying to prove a point. So 5, negative 10. We are saying that is right about here in our region, and that should be a solution. So if I plug that point into my equation, it should be true. So that means negative 10 is my y, so I put it in for the y. I go less than or equal to 2/3 x, which we have an x, now it's 5. Okay, and minus 2. Okay, 2/3, that's going to be 10/3. 10/3 minus 2. Well, if I just roughly do this, that's 3 1/3. So I'm going to get negative 10 is less than or equal to 1.3 repeating if I went back to decimals. The only reason I did that roughly estimated is because it's clearly this is true. Negative 10 is smaller than 1.3. So this is the right solution area. Okay? And we're going to keep going on this, but any questions so far? That's kind of the grand scheme of things. What you need to know today is you need to know that greater than or equal to, less than or equal to is a solid line. Greater than and less than is a dotted line. And you need to figure out whatever your best strategy is for testing above and below. So where you shade, above or below. Okay? All right. All right. So this is getting kind of weird. All right. Let's get to our example 2 here. This may help a little bit of clarity. That part before, they just talk about testing points. That's what we just did. So picking a point in the region you shaded, and you can test it. Okay, so y greater than x. Okay, so, Amanda, what do you think? Dotted or solid line? Dotted, right? And so there's no, think about it, there's no y-intercept, so that means I start at 0. My slope is 1, so I just go up 1 over 1. So it's just like that. It's just very simple. This is a basic linear line. And I can just go dotted through it. Dot, do dash lines. Okay, Rye, where do you think I shade? Above or below? Okay, so it says greater than x. Shade above. So I want to go from this point above. So I want to shade this area here. All this area here is a solution to the equation. Okay, why now? Let's think about this. Why now do I have a group of answers opposed to before when we would just solve? What is causing that? They can be, but do I have a single equal sign? No. What creates a multiple answers all the time is inequalities. Just like when we do a number line, we say it's -7 or anything behind it, right? So -7 to -infinity, I can do -10 million. That's an answer. Okay? I can do, for this one, I can go -30, 10. That's an answer. Okay? So it's kind of giving you a group of answers. Think about inequalities as groups of answers. All right, so we'll test the point last after we get all these. This one, I want to have y by itself. So again, I'm going to go ahead and solve. So -3x, -3x. I have -2y less than or equal to -3x minus 6. We're going to divide by the -2, which means I have to flip the inequality. Okay, so that gives me y greater than or equal to 3/2 x plus 3. Okay, so plus 3 means I start up 3. Okay, my slope is 3 up, 2 over. 3 up, 2 over. I'll also go reverse direction. Okay. Tristan, is it solid or dotted? Solid, good. And then Nick, am I shading above or below? It's greater than or equal to. Above. So that means I go to this point here and shade this region up here. Okay. Any questions on anything before we test some points? Okay, so Colton, give me a point in my shaded region that I can test. I don't care which point you pick. -3, 5. We're testing this point right here. We're testing -3, 5. Okay? All right, so this is kind of a simple one. 5 goes for y. Whoops, not equals. 5 is 5 greater than -3? Yes. That point is confirmed.
Your class change.
Okay. And give me a point try on this one, Sarah. Point part B. -5, 4. Right here. So we're trying -5, 4. Okay, I'm going to put it back in the original. So 3 times a -5 minus 2 times 4 is less than or equal to -6. 3 times -5 is -15. Minus 8 is -23. That is less than or equal to -6. We have confirmed it. Okay, so it is an answer. Okay, anything else before we get to the last 2 examples here? This is the gist of it. Okay. All right, I want you to go ahead and try number 3 on your own. I'm getting to it here. Try number 3 on your own. It's already ready to be graphed. You just got to graph it. All right, so what kind of line is it, Amanda? It's a dotted line, and where does it start? Like, if I'm graphing this, where do I start? Yes, you start, this is your starting point, okay, right there. Up 3, that's where I want to start. So this right here is kind of my landmark. So I'm going to come up here, 1, 2, 3, I'm going to put a dot. Okay, and then my slope's what, Tristan? Other way. Up 3, 1, 2, 3, over 4. Right here. That's your first dot. Okay, and then you can also go the reverse order. What I mean by that is instead of going up to the right, I go down to the left. So down 3, 4. See how that line kind of forms? Okay, and it's dotted like Amanda said. So here we go, we're dotted. Okay, Josh, shade above or below, you think? Good. So we're going below because it's less than. Okay, so I'm down here. That's our area we want. Okay, it doesn't have to test the point, so we won't test the point. But again, If the boundary line, right down here, if the boundary line is given the form of y equals mx plus b, then above the line represents greater than, below is less than. Now, the reason they're saying if it's in y equals is because if you solve that to flip the inequality, you can't just say from the beginning it's going to be below because it could change on you. Okay. All right. And this one here. So now they give us the graph, and we want to figure out what the equation is that made this graph. So we want to figure out what it is in this form. Okay, so looking at this line, let's take out a couple key points that I kind of want you guys to be able to recognize right off the bat. Is this a positive or negative slope? It's positive. It's going up to the right, right? Okay, did they shade below or above? Below. So then what are we thinking? Less than or greater than? We're thinking less than. Is it a solid line or dotted line? Solid. So we know we're going to have something like this. Y less than or equal to mx plus b. Our job now is to figure out the m and the b. Okay? Well, the b is where we start. That right there. Where's that dot? It's at 4. Okay? So the last thing I want to do is I want to figure out the slope. Now you can count or you can use slope formula. I'm going to use slope formula because sometimes it's harder to count if it's not right in front of you. This right here is slope formula. You've done this before. Okay, but I'm sure you might have forgot. It's not something you want to remember. All right, so you're just going to go 4 minus 0. If you're wondering what the 2's and the 1's mean, that means 0.1 and 0.2. x2, y2, x1, y1. So I'm just going to go 4 minus 0 and 0 minus negative 2. Minus a minus a plus, I get 4 over 2. So my slope is 2. So it's going up 2 over 1. Okay, so here we're done. Y is less than or equal to 2x plus 4. That is the graph to the right. Okay, again, you could have counted. So if you wanted to come over here and figure out, okay, right here it's at negative 2. I went 1, 2, 3, 4, 1, 2. You could have counted, got 4 over 2 as well. Okay, and in terms of inequality, we already did that, so part B is taken care of. This is the complete answer here. Okay, and that's it for lesson 4. Any questions? All right.